All right, welcome to the solution video for task 4. This is the crew allocations task, which is a much more involved task. And in fact, we're going to recommend that you use a different solver to solve this task because it's going to be more efficient. So if we go to use the CoinBC solver for this. All right, as usual, we want to open up the MZP file, which is going to load in the checker and a whole lot of data files. And we're giving you the starting point, which will read the data in. All right, and we can just check, for example, you can read the data in, you can get some error messages, something happens, right? So we have the staff that are involvable, the weekly salary of each of the staff, the skills, the total number of skills that are there using enumerator types here, the competence of each staff and each skill. Then we've got a vehicle, we've got a number of weeks that we've got to schedule. And for each week and for each vehicle and for each skill, we have a required competence. Remember, we have this constraint that a staff member can't work for more than max consecutive weeks in a row. And if it's 0, then there's no limit. And they can't work in the same, 2 staff members can't work in the same vehicle more than max together, number of weeks in a row. If it's 0, then there's no constraint. Okay. And so we've got in the first model, right, the basic model, for each skill, the combined competence of the crew in that skill is at least as much as required. So let's think about that. So let's put our constraints down here. So for each skill, the combined competence of the crew in that skill is at least as that much required. So basically, we're going to have to look on all vehicles. So if we look at our constraints, our required competence, right? For all W in weeks, V in vehicles, S in skills, we need to know that the amount of skill acquired to that vehicle is enough. Okay, so here we've got a variable set of staff being acquired. So basically we want to say that if we sum, so if we look at all the staff which are assigned to that vehicle, right? So we look at allocation, that week for that vehicle. Just checking that it's weeks and vehicles, yes. Okay, if we sum up, so that's all the staff, and we can't use S twice, so it's called ST for staff. Then we can look at their competence of that staff, all right? So we can look up for a staff in their skill, their competence. So the competence of that staff member with that skill has to be greater than or equal to the required amount, right? Required competence. For that vehicle, for that week, so that vehicle and that skill. All right, so let's see if it likes that. Undefined vehicle. Vehicles, I think it's because it's a vehicle. Is it skill or skills? Yes. Weeks, the only thing, weeks. Normally we don't put the S on. We have for weeks. All right. Okay, so something's going on, right? We're, okay, you can see that we're assigning people to more than one vehicle at one time. Okay, each staff member can only be allocated to at most 1 vehicle per week. So I guess we should possibly, so this is required competence. And this is most 1 per week. So what do we want? For all W in weeks, V in vehicles, basically we can't have, I don't know, so for all W in weeks, ST in staff, right? We need to look at every staff member. Let's count up in how many vehicles. So ST is in the allocation of that vehicle for that week. So that says, Project Explorer, for every week and for every staff, if we look at how many vehicles they're in, so ST is in the allocation for that vehicle and that week, then it has to be at most one. So we can have the staff assigned to no vehicle for a week. That's also fine. All right, we need to reduce the cost. Okay, so here's our cost variable, which is going to be our initial objective for doing the first part, 4.1. So let's determine the cost. So what does the cost equal to? Well, we have to pay every staff member for every week that they work. So we could sort of do it this way. We could say, okay, we have to we check if there exists a vehicle where the staff member is in the allocation, that vehicle, right, times their salary of the staff member. So that looks over all weeks and all staff and calculates the costs. Let's have a look. How are we doing now? Okay, we're getting some cost calculations going on. Okay, so we're so we aren't working out overall competence yet. That's fine. Okay, but that's not probably the best way of determining the cost, because we already said, right, that every staff member works in exactly at most one vehicle a week. So an alternate way of writing this would just be saying the cost, because we can just sum over all the weeks and all the vehicles. So remember what I said about exists and disjunction being not your friends, right? So we can just look at the staff in the allocation. Just summed up in two different ones. Staff in the allocation of that vehicle in that week times the salary of that staff. Now, we should actually, we've got solve minimize costs, so let's see how we go now. Hopefully it goes a bit quicker. Still finding lots of solutions, but I think that should be more efficient. Oh, in fact, we've got both. So that's not going to be more efficient. Whoops. I don't want to do that. Okay, so you should see that they end up doing the same thing, but because we've taken into account that you can only, because there's at most one allocation per week. Right. We're using G code. We want to use coin. That's why it's taking so long. Okay, there you go. That's why it shows you the difference there. So I changed it and then I loaded in the project and it reset it back to what it was. So remember, that will also happen the same thing. Okay, so have we finished our basic model? So I think so. If we look, we're getting part 1.1 is okay, which is all we've done so far, right? So everything's fine in terms of part 1.1 in all the solutions found there. So we do seem to have got part 1.1 working. Okay, now it gets more complicated. So there's this crew rotation and rest idea, which is very common in real world things, that we basically can't have two crew working together for too long, because what ends up doing is they end up not following the protocols, but having a shortcut, and that means the protocols aren't followed. We can't have them working too long together, and we can't have them working for too many weeks in a row. Okay, so let's say, the first one's probably easier, not too many weeks in sequence. So what do we want to look at? We want to look at all staff members and we're going to, how do we make sure that they don't work too many weeks in a row? So basically we want a list. Ideally, we want to probably introduce some variables. And actually this is going to be useful to go back and improve our previous model. Why don't we just have a variable for each staff, or for each week, because we've done it in this order normally, and each staff. Do they work on that week? Right? Does that, so this is just an intermediate variable. Now, in real modeling, it's very often useful to bring in these intermediate variables to store some information you're going to reuse multiple times. So what does it say? So we actually have the description. What does it mean that a staff works on a week, right? So this, so let's make it 0 to 1. We'll make it simpler because this number is obviously an integer. So this is the number of vehicles that they work on a week. We're going to force that to be less than or equal to 1. And of course, this is an array, right, for W in weeks, ST in staff of that. And now we can look at, we can do our costs using that. So basically, well, actually we don't need it here the way we've done it here. We've looked over all weeks and all vehicles. We could certainly, we could improve the previous one. And maybe this is a more natural way for doing cost. Okay, so we just say works in the week, the staff times salary, right? Because we're recording whether they work or not. So that's probably very efficient because we can, if we're going to use the same variable here, right? Let's just turn it off for a moment and just check that this works. Right, always check. Okay, so we've got a problem here. Obviously, we're not getting great error messages, but the problem is here. See this array? This is a 2-dimensional array, but this thing here generates a 1-dimensional array. So we're going to have to coerce it into a 2-dimensional array. And that's what these array coercions are. Right, so you can see the size of the array is weeks times staff, because that's how many times we iterate over. We have to coerce it into the right 2D array. Okay, now hopefully we get some better error messages. It was hiding at the top. Okay, so we're back to where we were, part 1.1 works. But now we've got these works 0, 1 variables, which tell us how often they work. So why don't we look at, for each week in, how many weeks are there? Number of weeks. So what we want to make sure is they don't work for more than max consecutive together. So n weeks minus max consecutive. Because basically we're going to have to sum up the number of times they work in a number of weeks. So if we look over the weeks in W, that's the first week, to W plus max consecutive. So notice that's max consecutive weeks plus 1 in total. Right? The sum of whether that staff works on that week has to be less than or equal to max consecutive. Okay, so hopefully that's understandable. For every staff member and for every week that's early enough that the max consecutive doesn't get us to the end, we look at all the weeks from W to W plus max consecutive, so that's max consecutive plus 1 weeks, and we say, well, you can't be working all of them. So if they were all, so if it's max consecutive plus 1, if that whole thing was max consecutive plus 1, that means you have been working in plus 1 weeks, right? Okay, and I've got an unexpected error because I've left off a semicolon. Okay, general expression must be par or var, set of int or one-dimensional array, but it is int. So it is here. Okay, so yes, this should be from 1 to n weeks times max consecutive. Okay, unsatisfiable. What's going on? So let's just look at the data we are running on. Max consecutive equals 0. Ah, remember there's a rule. There's also a rule that if max consecutive equals 0, then this doesn't apply. There's no constraint. And you can see why. Otherwise, it means that if you work for 1 week in a row, you break the constraint. So if max consecutive is greater than 0, we should apply this constraint. Otherwise, we shouldn't. So that's what the implication says. We just do a test. You can do if then else if you want as well. Since this is a fixed thing, this will be straight away checked out. Okay. So now, okay, we're getting past 1.2, which is good. Probably we would have, if we tried the earlier models, right? Okay, no, we are not getting, this is not, oh, okay. This is only, we only did max consecutive, but we're having obviously people working together for too long, which we haven't done yet. Yep. Okay. So that's not too many weeks in a sequence. So now we could also build up the an intermediate variable to hold that you don't work together too long. But since we're only going to use it for exactly one thing, let's not do that. So first of all, if max together is greater than 0, otherwise we don't have any constraint at all, right? So we're going to have to look at 2 staff members. And we don't have to look at all pairs, right? We don't have to look at pairs the same. And we're going to look at weeks. Similarly, 1 to n weeks, oops, minus max together. And we want to say that they don't both work on the same week. So we can just do that very simply. Okay, we're going to sum over these weeks, just like we did in the first one. Right, but rather than works of WST, they need to both work together. So we can do that by saying, if we take staff 1 and we take staff 2 and we add up their working numbers, if it's greater than or equal to 2, right, it can only be 2. So, yeah, as you can see, we're getting deep inside here. So we're looking from this start week W to W plus max together, which is altogether max together plus 1 weeks. We're counting the number of times these 2 workers both work at the same time, right? That will be true, and therefore add up, count as 1 every time both of these workers are working on the same week. That sum should be less than or equal to max together. All right. And I've left off a bracket or something, complaining about, oh, that's not that, it's less than or equal to. Okay. So hopefully now, okay, 1.2 is okay. Okay, that was the previous run. Yes. Okay, so we've fixed our problems with two workers working together at the same time. Look at the other data. Let's look at C3. Takes a bit longer. Okay, 1.1 and 1.2 are okay. All right, those of you paying attention may have realized that I have done something quite wrong here. And interestingly, the checker won't pick it up because what I've done actually is said that two people can't work on the same week together. But the definition of working together is to be working in the same vehicle. So this just says that they work in the same week. It doesn't say that they work in the same vehicle. So let's do it properly. Now, we're going to take advantage of the fact that since we know they're only working in one vehicle, this can only happen once. So we're basically saying if we look, do they work together? Well, if we look at the allocation in that week, which is week, okay, of the vehicle, then that's the number of times they work together, okay? So this thing will add up. So if they work in the same vehicle, they can only work in one vehicle together, right? Because they only work in one vehicle. So if the pair ST1, ST2 is a subset of the allocation to that vehicle for that week, then they work together. And the number of times that can happen is max together. Okay, so let's fix this. All right, we're missing a bracket there. I'll look at C1. Okay, so nothing wrong with that. Basically, let's have a look at some of the bigger data. Okay, so we've obviously made our model more complicated. So can find solutions. It's taking quite a bit while. Okay, let's prove the optimal solution in 20 seconds. All right, so now we've finished 1.2. Let's look at 1.3. So we're meant to not only minimize cost, but minimize the amount of competence that we use, basically. Sorry, maximize the overall competence that we use. So we worked out the cost, that was how much salary it is, and our objective was to minimize cost. Now let's minimize this objective, right? So we don't want to set it to 0, that's for sure. And we want to work out the overall competence. So what's the overall competence? Well, it's just how many, the total competence used, right, by the staff. So overall competence of the staff employed in each week. So how do we work out the overall competence? Well, we're just going to sum over the W in the weeks, and so it's of the skills that we require, I'm guessing, is the definition, right? So if we look at these are the skills that we're requiring, and that's what we're trying to maximize. So for all weeks, for all vehicles, for all skills, we sum up for the staff in the allocation their competencies. Okay, and we're probably missing a bracket. Yes, in the bracket. That looks good. So there's the overall competence, and now our objective is 10 times cost minus competence. Remember, because we're minimizing cost, this will maximize overall competence. Okay, let's try that simple starter first. Okay, you can see now we're getting all the parts correct in this particular simple data. How about we look at C2. It's taking so long, it's making me think that perhaps this constraint here is inefficient with respect to what it should be. Okay, but we're doing okay in 2. In fact, we can get the optimal in 20 seconds. 3 is a bit quicker. If it takes longer, that's the reality of optimization. Okay. Okay, and you can see here that, okay, in C3, we are not yet working correctly. Okay, we haven't done 1.4, but that's not surprising. Okay, so the problem with the model so far is it just takes an n-week block and it does whatever it wants there. But in reality, we'd have to think about what's going to happen with the next block, right? Because some of these competence and working together would travel onto the next block. So how are we going to fix this problem? So you can see that basically we needed to well, we used this working stuff. We're now going to have to think about making these constraints here apply across the entire cyclic sequence. So what we're going to do is build up some extended version of our allocation array. Okay, so let's think about how many weeks we need. So it's called extended weeks. Is the number of weeks, right? Because we're going to have to look at every max together or max together plus one length period of weeks together. And we're going to have to look at every max consecutive weeks together. We're going to need to add on a number of weeks equal to the maximum of max together and max consecutive. All right? So we're going to add these on because we're going to need to look at these kind of chunks. So let's call our set of int extended weeks, right, is 1 to x weeks. And now, this is a trick that we commonly do in cyclic scheduling. Basically, we know that we've got the original weeks, and then the first week here is going to be, the first week afterwards is just going to be a copy of the first overall week. So we can do that by adding constraints. Right, so for all wn, well, it's 1 to max together. So this is the extra weeks that we had. Max consecutive. So we just need these extra weeks that we added on the end. Remember, they're copies, because basically we're going to run the same allocation all the time. So the allocation in this week plus n weeks, right? So this is that one added on the front. We're going to need to, yes, we're going to need to extend this array, right? So we're going to have a copy of this array. I did not copy. So we can have a copy of this array called x weeks. It's called the extended allocation. The extended allocation of this week, right, equals the allocation at n weeks up at week W for each vehicle. So that should be, okay. Whoop. So these are the extra weeks on the end. So that's forcing the extra weeks in X allocation to be correct. We also need that the original weeks are correct. And we probably could have done this better actually, but we can just say, right, for the original weeks, the X allocation is equal to the allocation. Just check that that's all fine. We haven't done anything yet with that original weeks, so we're still going to get the same error. Now we've got an extended allocation. So since we used, so we're doing this, so we still haven't fixed anything, right? We're doing this to be able to get these things to work. So here we use works week ST, but that's only done for the original weeks at the moment. So since it's a variable anyway, we can just extend it, right? So we just looked over X weeks and we use the extended allocation, and that's going to work out. So now work is defined over multiple weeks. And now we can look across this. So now we don't go to N weeks, right? We go to, I go to the name, X weeks. Right, so we're looking at all copies of weeks of size max consecutive from 1 to X weeks minus max consecutive. And we're checking that number of times that that staff member works is not too long. And we've extended work so that that's correct. And here again, this is going to become X weeks, right? And we're using the extended allocation. And we check that they aren't working together that often. And I think that's all we need to do. Okay, so the cyclic scheduling is even, obviously is going to make things run slower. We have to run it on some data where it wasn't working, so C2, okay. Okay, so here's the old version of C2 where Edgar and Steve worked together for too long, 4 to 6 and 5 to 7. If we look at the C2 data, which I've lost for some reason, you can see the number of weeks is 5. So basically these are in the cyclic space. Yep. So that was the old solution. Now the new solution, that's all gone and all of our things are correct. Okay. So here we used a trick which is common in cyclic allocation. We took our original allocation variables, which is all we care about. We built an extended version of the array that we wanted to use, right? So this is just extending for these extra weeks, which is this number of extra weeks. We just set them to be all the same, right? Except that the extra weeks get the original weeks, because basically we put a copy of the start of the schedule, the original schedule on the end. And then we extended our works array to work on this extended weeks, because that was simple, just using the extended allocation to work it out. And then we could basically rewrite each of these to use the extended weeks rather than the original number of weeks to make sure that we didn't work too long together. All right. And that brings us to the end of task 4. So I hope you've seen, you've gone through some increasingly more difficult models, increasingly more complicated and getting more realistic. And you've seen some of the power and flexibility of MiniZinc to be able to tackle these kind of problems. Thank you very much.